Hi and welcome. So today we're going to continue talking about section 10.4. We've been talking about the inverse trig functions. We talked about inverse sine, inverse cosine, and inverse tangent. And today we're going to be focusing on evaluating expressions involving the inverse trig functions. Before we start evaluating expressions though, I want to remind you about the three graphs that we talked about last time, and I have them written over here. And so we have our inverse sine function, also called arcsine function. The thing that is most important about these graphs in terms of evaluating expressions involving inverse trig functions is identifying the range for each function. So for arcsine, our range has y values from negative pi over 2 to positive pi over 2. For inverse cosine or arc cosine, our range, the possible outputs, are 0 to pi. And for arctangent, our graph down here, our range is negative pi over 2 to positive pi over 2. So while those may just seem like factoids at the moment, those are going to play a really important role in terms of making decisions about how to evaluate each of these expressions. Okay, so let's look at an example. So in our first example, we are asked to find the exact value of the expression inverse sine of square root of 3 over 2. Okay, now that we have both the trig functions, sine, cosine, and tangent, and the inverse trig functions, arcsine, arccosine, and arctangent, inverse sine, another name for that is arcsine, I want to think really carefully about what it is we're looking for. Okay? When we have an inverse trig function, the thing that we are looking for, this thing inside the box over here, that is going to be an angle. And the thing inside the parentheses, the input into the inverse sine function, is a ratio of sides. And this kind of makes sense because when I think about the original function, sine of theta is opposite over hypotenuse, so the input is an angle, and the output is a ratio of sides. In particular, for the sine function, the output is the opposite side over the hypotenuse side. So when we look at the inverse function, we're flip-flopping the input and output. So now our input is a ratio of sides, and the output that we're looking for is an angle. Okay, so thinking about some information here, I want to start by thinking about the range for inverse sine. So inverse sine of x, the range is negative pi over 2 up to positive pi over 2. And I can remember that a couple of different ways, but for me, one way to remember it is on this graph of arcsine or inverse sine, the y values go from negative pi over 2 to positive pi over 2. Okay, so what this tells me when my range is negative pi over 2 to positive pi over 2 is if I'm thinking about the xy plane and I'm thinking of sort of a circle of angles, maybe I can think about the unit circle here. What I'm thinking about is I am looking for angles that are on the right-hand side of this circle. Okay, angles that start at an angle of negative pi over 2, swing counterclockwise up to 0, and then swing up to a positive angle of positive pi over 2. So I'm looking for an angle in either quadrant 1 or quadrant 4. Okay. All right, so once I identify that means that there's no way that I'm going to be choosing an angle in quadrant 2 or in quadrant 3. They are just not allowed. All right, the second thing that I observe here is that our ratio of sides, the input into our arcsine function, this input root 3 over 2, our ratio of sides, in this case, is positive. And so of my two choices, either quadrant 1 or quadrant 4, I want to ask myself, is the sine function positive in quadrant 1 or quadrant 4? And the answer is sine is positive in quadrant 1. So just from those two pieces of information, I know that my angle that I'm going to get as an output is going to be an angle that I'm going to draw in quadrant 1. So I'm going to draw a new picture in quadrant 1 because the one up there is already quite scribbled on. So here's my angle. I don't really know what the angle is just yet, but I know that it's going to live in quadrant 1. The next thing I want to do is I want to look at this ratio of sides. And our ratio of sides is square root of 3 over 2. And because we're looking at inverse sine, that inputted ratio is opposite over hypotenuse. Or you can think about this as y over r. So on my diagram here, I can identify the y value as square root of 3 and the r value is 2. And then I ask myself, do I recognize this triangle? And the answer is, yeah, I do. I like this triangle a lot. This triangle right here, I know that the third side on this triangle is 1, and this is going to be an angle whose a triangle whose reference angle is 60 degrees or pi over 3 radians. Okay? So back to our question, find the exact value of inverse sine of root 3 over 2. The answer is that the inverse sine of root 3 over 2 is pi over 3. Okay, so another way to think about this is that the sine of pi over 3 is root 3 over 2. Okay, so we have evaluated our first example. Arc sine of root 3 over 2 is pi over 3. Okay, the input into the inverse sine function is a ratio. The thing that we're trying to get, the output, is an angle. Okay, let's look at another example. So same instructions, find the exact value, and this time our expression is inverse cosine of negative root 2 over 2. Okay, so we want to fill in this box over here on the right side. When I'm talking about an inverse function, an inverse trig function, the input is a ratio of sides, which in this case, because this is inverse cosine, the ratio of sides will be adjacent over hypotenuse, or x over r. And the output that we want is going to be an angle. Now, when I think about the arc cosine or inverse cosine function, the inverse cosine range, well, let's see, if I remind myself about this, the inverse cosine function has y values that go from 0 up to pi, so our range is 0 to pi. Which means in terms of angles that I can choose from, we are allowed to choose angles that start at an angle of 0 and extend to an angle of pi. So we can choose any angle on the top half of this circle. We cannot choose angles in quadrants 3 or 4. Okay? Okay, the next thing I want to think about is I want to look at the ratio that we have, and the ratio we have, negative root 2 over 2, is negative. And so in terms of the two quadrants that I can choose between, quadrant 1 and quadrant 2, the cosine function is positive in quadrant 1 and negative in quadrant 2. So cosine is negative in quadrant 2, so that tells me that my angle is going to live in quadrant 2. Okay, so now I'm ready to draw this angle. The angle is going to live in quadrant 2, and so I'm going to draw my reference triangle. Okay, now looking at this number that I have, this negative root 2 over 2, I might recognize this, or hopefully I do recognize that this is a fraction that's already been rationalized. So the real value of this, before it's rationalized, is negative 1 over root 2. And now looking at this fraction, I'm thinking to myself, okay, this is arc cosine, so our ratio is adjacent over hypotenuse, or x over r. So in my picture, my x value will be negative 1, my r value will be square root of 2, and as soon as I see those values, I can immediately identify that this is going to be our 45-45 right triangle. So our reference angle is 45 degrees, or in terms of radians, pi over 4. Okay, so we've just figured out that the angle that we're looking for has a reference angle of pi over 4. And so I can either identify what the degree measurement is of this full angle, this is the theta that we want, or I can think about it in terms of blocks of pi over 4s. So blocks of pi over 4s, I'd have 1 block of pi over 4, 2 blocks of pi over 4, 3 blocks of pi over 4, and that gets me to the terminal side. So that tells me that our angle of theta is 3 pi over 4. Okay, so that tells me what this angle is going to be, and our final answer is that inverse cosine of negative root 2 over 2 is equal to 3 pi over 4. Okay, so those are our first two examples. We're going to look at some other expressions that are going to get a little bit more complicated than some of these, but what I want you to think about on these examples where we have inverse trig function of our input is a ratio of sides, and we want to figure out an angle, it's really important to know which quadrants am I allowed to choose that angle from. And that's going to play a key part in our next few sections of this class. Okay, thanks.